recall that the scale problem arises because we have tens of thousands of servers on a flat layer 2 topology, where all of the servers have a topology-independent MAC or hardware address, and thus, in the default case, every switch in the topology has to store a forwarding table entry for every single MAC address. One solution is to introduce what are called pods and assign pseudo MAC addresses to each server corresponding to the pod in which they're located in the topology. So in addition to having a real MAC address, each server has what's known as a pseudo MAC address, as shown in pink. Thus, switches in the data center topology no longer need to maintain forwarding table entries for every host. They only need to maintain entries for reaching other pods in the topology. Once a frame enters a pod, the switch then, of course, has entries for all of the servers inside that pod, but they don't need to maintain entries for the MAC addresses for servers outside of each pod. For example, the switch in pod 1 only needs to maintain entries for these two servers with MAC addresses A and B, but it doesn't need to maintain independent entries for the servers with MAC addresses C and D. It only needs to maintain an entry for how to reach pod 2. Likewise for pods 2 and pods 3. Now, in such a data center topology, of course, these hosts are unmodified. So they're still going to respond to things like ARP queries with their real MAC addresses. So we need a way of dealing with that, as well as a way of mapping pseudo MAC addresses to real MAC addresses. The solution is as follows. When a host, such as server A, issues an ARP query, that query is intercepted by the switch. But instead of flooding that query, the switch intercepts the query and forwards it to an entity called a fabric manager. The fabric manager then responds with the pseudo MAC corresponding to that IP address. Host A then sends the frame with the destination pseudo MAC address, and switches in the topology can forward that frame to the appropriate pod corresponding to the pseudo MAC address of the destination server. Once the frame reaches the destination pod, let's say in this case pod 3, the switch at the top of that pod can then map the pseudo MAC address back to the real MAC address, and the server that receives the frame receives an Ethernet frame with its real destination MAC address, so it knows that the Ethernet frame was intended for it. By intercepting ARP queries in this way, and providing a mapping between topological pseudo MAC addresses and real physical MAC addresses, we can achieve hierarchical forwarding in a large layer 2 topology without having to modify any host software.